Hello, welcome to this RStudio tutorial in which I introduce some simple graphical routines. To begin with, let's introduce some data. I'm going to define the variable maxd as 10. That's the maximum number of observations of data points that we have. And our data will comprise 10 values for storks and 10 values for babies. Now let's allocate to these vectors the specific numbers, and for this I'm going to use a loop. I'm going to go from I is equal to 1 all the way through to max d, so I'm going to go I is 1, 2, 3, 4, 5, 6, 7 all the way up to 10, and then each time setting the ith element. So here we are, and here the ith element for the storks is a number drawn from a normal distribution with a mean I times 100 and a standard deviation of 10. Likewise, let the vector babies, whose elements I have a mean of I times 10 and a standard deviation of 10, be set like that. We'll just close that bracket now. And if we want to plot the relationship between storks and babies, then we can use the default plotting function, which is simply plot. So we go plot storks of babies. Now sometimes when we have a continuous response and a continuous predictor, we may wish to draw a line which most closely fits that relationship. And here's how we would do that. It's with abline, where we fit the linear model between babies and storks, and abline will simply draw the fitted model onto that graph. Now let's say we've got some new stork data collected in the current year. Of course, one way is to simply write it down as a new vector for new stork data, and here are new data on the number of children born. We may wish to plot these data on the same graph, and how would we do that? Well, we can simply use points to draw existing data points on current graphs. So here we are, points for new stork data against new baby data, and just to show that we can distinguish them, well, we are putting red coloured dots, and we're filling in those dots by choosing a symbol PCH equals 19, which gives us filled dots. Now of course we can fit a model to just these new data in very much the same way. We can have abline here, where this time we're fitting a linear model between the new baby data and the new stork data, and just to keep the colours constant, I'm referring to that colour as colour red here. Now in some cases it may be useful to define using a legend what these individual points are referring to, and there are a number of ways to do that. The simplest is simply to call up legend as part of a graphical function, and here is one way of placing that legend here. What I've done is use the locator, which will allow me here to work out broadly where I would like the relationship to go, and then click and it's there. We have here the old data, new data as the text for the legend, the different symbols, whether it's open or full, as the 1 or 19 for the PCH, and of course we've got black or red for the colour. Now sometimes it's of use to actually draw two graphs on the same individual graph rather than one. How would we do that? Well, the easiest way to do that is with a simple graphical routine here, which I'm going to be calling up. It's simply par. Par sets the parameters of any graphs, and here what we have is subsequently we are going to have a matrix plot of graphs with one row and two columns. And what I'm going to do, I'll omit the legend the next time, but I'm going to draw one of these sets of graphs simply again. Here we are, the storks and babies, along with the new data, just so that you can see it in one set of one area of that graphing plot. So here we have the very first part of that overall graph set here. Is the original graph. But we can use that par function to set a range of other attributes of the graphs that we draw. So for instance, here are some common ones that we might choose. We can set LAS, we can set the label to actually go horizontal rather than vertical as it's described by the default. We can also, for example, have here the label sizes increased by about 20%, and here we can have the numbers themselves increased by 10%. Now after doing this, what I'm going to do is the same graph, and of course most of the time we would have a different graph plotted here, and let me run that now here. But you'll notice that these are with the slightly different increased in size text, and of course what we can see here are that the labels are now left horizontally. So you've seen a variety of different things here in this very simple introduction to graphics. First of all, you've seen the default plotting function, but then you've seen how we can use various arguments of those plotting functions. We can set through par, for example, how many individual plots we would like in a given screen, but also the sizes, fonts, and orientation of the labels. Thank you for listening to this R Labs tutorial video. If you found this useful, you might be interested in our free online Moodle course, or check out and subscribe to our YouTube channel.